The last learning intention we have with algebra in first year is using linear equations to solve word problems. So that's what we're going to focus on in today's video. Here's an example, and I think our best way to approach this topic is to jump straight into some examples and try and see can we figure out how to apply these. So first off, the first question asks us, what number is 1 bigger than x? So imagine x is a number. We want to figure out what number is 1 bigger than that. So you can pause the video right now and have a think about that. What number would be 1 bigger than x? So imagine I took an example and I said that x was a number, and let's say I said it was 10. Well, 1 bigger than that would be 10 plus 1, which would be 11. So imagine I take the number x, which is 10, and I say, well, it's x plus 1, and then x plus 1 is 11. So what number is 1 bigger than x? Well, the number that's 1 bigger than x would be x plus 1. So our answer for part I is x plus 1. That's a number that is 1 bigger than x, no matter what x is. X could be any number, and if you add 1 to it, it's going to be 1 unit bigger. The second question says, the sum of two consecutive numbers is 47. Find the two numbers. So first off, we have to think, well, two consecutive numbers. That's a phrase we might not recognize. So two consecutive numbers. So a consecutive number, for example, or a pair of consecutive numbers would be 2 and 3, or 15 and 16, something along those lines. So two numbers that are one after another. So absolutely loads of ways of doing this. One way would be to say that, well, one of the numbers, we don't know what it is. We could say that it's x. The other number, we don't know what it is, but we know it's 1 more than it, so it's x plus 1. And we know that if we add those two together, it'll be equal to 47. So we could have x plus 1 will be 47, where x is the first number and x plus 1 is the number that comes after it. So then we'd have x plus 1 is 47. Then we would have 2x plus 1 is equal to 47. Well, then I have to use my algebra rules. I have 2x plus 1 is equal to 47. I have a plus 1 on the left-hand side of the equals, which I don't want to be there. So I'll subtract 1 from the left-hand side and subtract 1 from the right-hand side. Then what I'll be left with is 2x is equal to 46. Then what I'll have to do is I'll have to check, well, if 2x's are 46, I'll have to divide both sides by 2, and I'll find out that x is equal to 23. So the question asks us to find the two numbers. Well, one of the numbers is 23, and the next number was 24, because it's x plus 1. So x is equal to 23. The next number, x plus 1, was 24. So they were our two numbers. So 23 and 24. Now, in our next example, we're told that Porrick and Paul have a combined age of 111. And Porrick's age is twice Paul's age. And we have to try and find out how old Paul and Porrick are. So simply enough, we can think, right, well, we have poor old Padraig. That'll be Padraig. So we have Padraig and we have Paul. And their age combined is equal to 111. And we know that Porrick is twice as old as Paul. So Porrick is twice Paul. Well, I've tried and convert this into algebra, and I think what my variables are. So imagine if I said that Paul's age was equal to x. Now, imagine I said that Porrick is twice as old as Paul. How do we represent twice as big as x in algebra? Pause the video and think about that right now. So if Paul's age is x and Padraig's age is equal to twice x, because it's 2 times bigger than it. So we have Paul's age is x, Porrick's age is 2x, and we've already said that Porrick and Paul is equal to 111. So then we can say that, well, we've already said that Porrick and Paul is 211, so we have 2x plus x is equal to 111. That means 3x will be equal to 111. So 3x is equal to 111, but what we'll have to do, same as usual, if 3x's are equal to 111, check what the variable or the number in front of the variable is. It's a 3. So we're going to divide both sides by 3. So 3x divided by 3 is equal to x. Oops, forgot to include these. And 111 divided by 3 will be equal to, oh, give me a second till I think this through. So we'll have 90 would be, that'll be 30, and then we have 21 would be 7, so 37. Yes, that makes sense. Okay, so you could again do that in your calculator. I did that in my head. So 111 divided by 3 is 37. And now, as usual with algebra, we can always check our answer. So if Paul is Porrick is twice Paul. So we have twice 37 would be 74 plus 37. And is that equal to 111? We can check. Yes, it is. So that means that Paul and Porrick, when you combine their ages, is equal to 111. Our next example involves an electrician. The question starts off, an electrician charges 30 euros per hour and spends 20 euro a day on diesel for his van. We need to write an algebraic expression to represent his earnings for one day. Okay, so the one thing we do know is that he earns 30 euros per hour. What we don't know is how many hours he works. And the thing about being an electrician is the amount of hours you work might change day to day. So how many hours is what we don't know. How could we represent the 30 euro that we do know and how many hours that we don't know in algebra? Pause the video and think about that. Thinking that 30 euro we know is how much he earns, but how many hours we don't, and that could vary. So, what we know is that 30 euro, but what we don't know is how many hours he works. So if he works 1 hour in the day, he'll bring home 30 euro. If he works 2 hours in the day, he'll bring home 60 euro. If he works 10 hours in the day, he'll bring home a mighty 300 euro. So the thing that varies in each of these was the amount of hours. So we could say the equation to represent what he earns is 30x, where x is the number of hours. But what we also need to keep in mind is that the question said he spends 20 euro a day on diesel for his van. So if he has that fixed cost every single day, whatever he earns, we'll have to subtract 20 from. So give me 1 second here, let us move this over slightly. So if we think about what he earns for when he works 1 hour, well, we have to subtract 20 from that and he'll only bring home a tenner. When he works 2 hours, we have to subtract 20 from that, he'll only bring home 40. Or when he works 10 hours and brings home 300, he'll only bring home 280. So when we think of our equation in algebra, we have 30x for the number of hours, but every single time, regardless how many hours he works, he's going to spend 20 euro a day on fuel. So the equation we have to represent the number of hours he works, or how much money he brings home, is 30x minus 20. The second part of our question says that our electrician earns 160 euro in one day. How many hours has he worked? Well, like most algebra questions, we think, well, we've already figured out that we have 30x minus 20 represents how much money he'll take home. We've been told in this specific day, he brings home 160 euro. Now we have an equation which we can solve. He's worked 30x hours, we have to take away 20, and that's equal to 160 euro. We need to figure out how many hours. So the thing that is the variable is the hours. So we have 30x minus 20 is equal to 160. And we have to take away 20 from both, or add 20 to both sides here. So we want that negative 20 to go to the other side of the equation. So we need to add 20 to both sides of our equation. And we're left with 30x is equal to 180 euros. Then we have 30x divided by 30 is equal to 180 divided by 30. Then we have x is equal to 180 divided by 30 will leave us with 5 hours worked. Wait, no, that's... all right. No, 6 hours worked. Sorry, 6. Oops. Change that to a 6. So he has worked 6 hours. And our solution is just here below. The questions I have for you to complete today are from activity 14.5 in the Algebra 2 chapter. So I want every student to fully complete one level. The level 1 questions would include question 1 and question 2. The level 2 questions would include 4, 5, 6 and 7. And level 3 questions would include 10, 11, 12, 13 and 14. Now, before you start into the questions, I'm going to do an example of how to form the equation for question 1. So if we look at question 1 and I take, we'll say, question 1 part 1 as the first example, forming the equation. So it says 4 times a number plus 6 is 50. Okay, well, something is going to be equal to 50. 4 times a number, so 4 times something we don't know, plus 6 is equal to 50. Well, the something we don't know, well, in algebra, we use a letter to represent that. So I'm going to use the variable x. You could use a, you could use b, you could use any letter you want. So I can say 4x plus 6 is equal to 50. So now I have to think, well, if 4x plus 6 is equal to 50, and I subtract 6 from both sides, I'll end up with 4x is equal to 44, as the 6 minus 6 will cancel each other out. So then when I have 4x equal to 44, well, if 4x is our 44, I check what's the number in front of the variable, what's the coefficient? Well, it's 4, so I'll divide both sides by 4. Then I will have x is equal to 11. So this means that 4 times 11 plus 6 is equal to 50. So 4 times a number, the a number we figured out was 11. Now, I would expect everyone to be able to form the equation. So everyone should be able to find this part. Everyone should be able to do this for question 1. The trickier part that we should still try to do is finish out the equation to end up with an answer for the variable. But everyone should be able to try and make sure they solve this bit out for level 1 questions. Thanks and good luck with the questions. Any questions?